Okay, hi everyone. Welcome back to my personal channel. Today's talk has a very purposeful title: Free Code, Expensive Judgment, Managing Software Engineering Teams when AI Agent write code for you. So this is a view from the tech director or software engineer manager. And the free code part refers to what AI agent have made possible. PR throughput growing at 21 times in 3 years, pipelines built in 40 minutes instead of 2 days. The expensive judgment part is what this talk is actually talk about. What becomes more valuable and what is less so expensive, and when the code generation is no longer the bottleneck. I will grant everything in real data from two of the most active open source AI projects in the real world, VLLM and HG9, and also talk about 6 evaluation metrics and introduce 4 self-defined areas, 3 guiding questions. So let's get into it. So first of all, let's quickly walk through what we will cover today. On the left side of this slide is our agenda. We will start with a shorter prologue, the 40-minute pipeline to set up the stage. Then we will explore the 4 areas of the AI coding in engineering that I defined based on the development of the AI coding in the past few years. And then it will be followed by why we choose VLM and HG9 as our real-world study case. Next, we will dive into the real-world data analysis, use the 6 key metrics tracked and evaluated across those 4 areas. After that, I will share a practical leadership framework, and then we will look at the human singulars that matter most when working with the AI. There is also a special note for the life science teams. Now we will close with 3 fundamental and uncomfortable truths, plus some key takeaways for today's lecture. So this Intel journey is designed to give you a clear and data-informed view of how AI is reshaping the software engineering leadership. Now, turning into the right side of this slide, these are 3 key guiding questions this talk is built to answer. So the first question is, as AI coding capabilities continue to accelerate rapidly, how should engineering managers and tech directors actually lead their teams? The second question is, how do we detect and evaluate meaningful shifts in the human-AI collaboration patterns? And the third, how can we measurably improve our team's ability to deliver high-quality code in this new reality, especially for the high-quality production and deployment code base? So these 3 questions will serve as our roadmap navigation for the next 40 minutes. By the end of this today's session, you will have concrete answers, evaluation metrics for the agentic coding, and the software engineering leadership framework that you can take home and apply with your own teams. With that, let's jump in, starting with the prologue on the slide number 3. So let me start with the moment that crystallized for me. So in the earlier 2025, I'm reviewing a pull request from a junior engineer, a pipeline for the automated biofilm segmentation from the any image analysis. So the code is clean, and the logic is sound, and the comments are unusually thorough. The PR has been open for less than 4 hours. I approve it and merge it and move on. Later in one-on-one, the engineer mentioned almost in passing, oh, I used a crowd code for most of that. And it took me about 40 minutes. 40 minutes of pipeline that would have been taken 2 days a year earlier. So I did not feel threatened. I feel that the ground shift. Because the question had changed, it has no longer how fast can my engineers write code. It was, how do I need a team where the bedrock is gone? That is what today's talk is about. Before we look at the data, we need a shared vocabulary for the timeline. I defined 4 areas based on the availability and adoption of the AI coding tools. Area 0 is a pre-agentic baseline. Before Copilot was generally available, AI was autocomplete, nothing more. So area number 1 is began with when the Copilot goes GA in October 2023. SGLang launches in January 2024. Devin, the first autonomous AI software engineer, debuts in March 2024. Engineers start experimenting seriously with the AI agent for coding. Area 2 is when the vibe coding goes mainstream. The phrase enters to the engineering domain. AI-generated code becomes a routine, not an experiment anymore. So area number 3 is where we are now. Cloud Code goes GA in February 2025. Cursor Agent in June 2025. AI agents are submitting PRs autonomously. The team's role has shifted from the implementation to orchestration. So from the area 0 to the area number 3, and this kind of boundaries are not arbitrary. They are correspond to measurable inflection points in the data. I choose these 2 projects deliberately. Both are fundamental AI inference framework. The infrastructure that makes the large language model deployed possible at scale for the inferencing. Both are maintained by world-class engineers teams who are themselves AI practitioners that I totally believe in today's AI engineering and practice work. So this makes them ideal natural experiments for using the AI coding. So these teams are not just using AI coding tools, they are building the infrastructure those tools run on it. If any engineering teams in the world would adopt AI-assisted development earlier and deeply, I think it is these teams. So the data spans 41 months for the VLM project and 30 months for the SGLang project. Over 53,000 PRs combined. I tracked 6 metrics monthly across all 4 areas. The next section drives into each section one by one. Each areas one by one. And this is where we start answering the first of our 3 guiding questions. So this is the first of our 3 guiding questions, and it is the management question. As AI coding capabilities accelerates, and the data we just saw shows it is accelerating dramatically, how should engineering managers and tech directors actually lead their teams? The next 7 slides answer this with some data and matrix evaluation. 6 metrics tracked and evaluated monthly across 4 areas of AI tooling adoptions. Each matrix will tell you a different part of the story, and together they will give you a framework for what good looks like in the agentic AI coding era. The throughput numbers are frankly staggering. VMM went on the area 0 age of 38 merged PRs per month to area 3 average of 796, a 21 times increase. If you look at the figure 1 of the monthly PR throughput for the VMM. If you look at the number, the SGLang time series changes. SGLang launched in area 1 with 42 merged PRs per month and reached 742 in area 3, a 17.8 times increase from its own baseline. So by June 2026, SGLang was merging over 1,370 PRs per month, overtaking VLM despite the launching 11 months later. So these numbers are only achievable if AI agents are generating, testing, and submitting a significant fraction of the PRs. The question for engineering leaders is not whether your team will reach this scale, it is whether you have the review infrastructure and architectural clarity to absorb it when you do this kind of PR submissions. Throughput without quality is noisy. So let's look at the figure 2. And if you look at the PR cycle time, the time from PR open to merge is the first quality single. VLM's all-time median is around 0.26 days, For the SG9, it's about 0.04 days and 1 hour. So that is extraordinary. In a traditional software engineering team, a median cycle time of 0.26 days would be considered exceptional. For SG9, it is the all-time average. So this is the signature of the AI-assisted development. Not just the PR, more PRs, not just more PRs, but PRs structured for faster reviews. AI agents generate a focused single-purpose PR with clear descriptions, because that is what they are planned to do that kind of manner. But I think there is a leadership warning. If the cycle times are faster because the reviewers are rubber stamping AI-generated code, that is the process failure, not a success. Building automatic checks, lighting, testing, security scanning, and then that run before human reviews. So let the machines catch this kind of obvious problems, so humans can focus on the subtle ones. So that's what the metric 2 tells us regarding the PR cycle time. One of the most persistent concern about AI-assisted development is that it will concentrate contribution. And that is a small number of engineers with strong AI tool skills will dominate, while others are marginalized. So the figure 3 shows tell us a different story. VLM grew from 11 unique contributors per month in era 0 to 44 in era number 3. But SG9 grew from 13 to 39 from the era 0 to era number 3. Both show strong and statistically significant upward trends, and the growth accelerates in era 3. The interpretation is from this figure is that AI tooling is expanding the contributor pool, not concentrating it. Engineers who previously lacked the confidence or context to contribute to a complex code base can now use AI tools to lower the activation energy for their first PR. For the engineering leaders, this is both an opportunity and also a moral responsibility. You can grow your contributors base faster than ever, but you need an onboarding infrastructure and review and a better review culture and architectural documentation that can absorb a rapidly expanding pool without sacrificing the coherence. The heat map in the figure 4 is the synthesis view. 6 metrics, 4 areas, and 2 projects, all normalized, so you can compare across the dimensions. The pattern that jumps out, the matrix degree as AI tooling adoption increase, throughput rise, cycle time compress, and contributors grow, comment density rates, which we will explain in the next slide. They will merge, the merge ratio stays stable, new authors ratio stays healthy. So this is the empirical answer to this question. Does AI-assisted development come at a quality cost? So in these 2 projects, and over this time period, from era 0 to era number 4, the answer is 0. Is no. Velocity and the quality move together. So that does not mean it is automatic. These projects have strong review cultures, clear architectural vision, and active maintenance. So the data reflects that what good AI era engineering looks like, not what happens by default. This is the finding that surprised me most, and I think it is the most important one for the engineering leaders from the figure 5. The conventional assumption is that AI-generated PRs would reduce review discussions, right? And the reviewers would rubber stamp clean and well-formatted code. The data says the opposite of this view. So actually, if you look at the figure 5 for the VMM, it went from the 0.92 comments per PR in 00 in era 0 to the 11.67 in era number 3, a 12.7 times increase. But the SG9 went from 0.73 to 7.21, a 9.9 times increase. With that kind of increase in VMM and SG9 comments across the 4 eras, the interpretation for this kind of changes is that AI era PRs are architecturally larger. They touch more files, span more subsystems, and propose more significant changes with the AI coding. So this generates more review or discussion, not nurse. Human judgment is not being replaced. It is being applied to be a bigger and a more consequential problems that I'm thinking. So for engineering leaders, this means your senior engineers are not becoming less relevant. They are becoming more relevant because they need to review more complicated changes and large scale or large PR submissions. The bottleneck is shifting from code generation to the architectural judgment for the senior software engineers. The final metric is about the sustainability, about the contributor diversity. A project that only attracts new contributors and loses them in a leaky bucket. A project that only retains existing contributors is a closed club, and the health pattern is a mix. So both VLM and SG-line show that mix. In Era 3, if you look at the figure number 6, VLM has roughly 54% new authors per month, meaning about half of each month's contributor are first-timers. SG-line is at around 57%. The returning contributor space is growing in the absolute terms, even as the new contributor ratio stays high. So this is a sustainability signal. AI tooling is not just accelerating existing contributors. It is continuously expanding the pool of the software engineer who can contribute meaningfully for the open source project. For engineering leaders, and I suggest that this means your onboarding investment has compounding returns. Every new contributor you successfully onboard becomes a returning contributor who helps onboard the next wave. The AI tooling, AI coding lowers the barriers to entry. Your culture and your documentation determines whether people can stay for a longer time. And also this slide is about the leadership framework that connects the 6 metrics to 6 concrete leadership practice. The key insight is that each metric is not just a measurement. It is a signal that tells you something specific about how your team is operating in the agentic era, and it points to a specific leadership action. Throughput tells you about the velocity, but only if you compare it to a right baseline. Cycle time tells you about the review speed, but faster is only good if your automatic checks are catching what humans should not have to catch. And contributor price tells you about the community growth, but growth without onboarding infrastructure is churn. Comment density is the one that surprises most leaders. Rising comment density is not a sign of the inefficiency. It is a sign that your team is tackling architectural ambitious problems. If comment density is failing while throughput is rising, and then that is the warning signals. Take this table back to your team. I think that should be the most important take-home message. For each matrix, ask what is our current number? What areas are we in? What is one practice we could implement in this quarter to improve it? The 6 matrix tells us what is happening. This slide asks, what does it mean for how we lead? So the judgment gap is the space between what AI agent can do and what engineering leadership requires. AI agents are excellent at execution, generating code, following patterns, writing tests, but they struggle with some judgment, knowing when not to build something, detecting architectural shift and drift before it becomes technical debate, reading team morals and negotiating scope. So these are not skills that can be automated away in the next model release. They require organizational context and also historical awareness, and this kind of trust is built through the sustained human relationships. The implication from this slide for the engineering leaders is that counterintuitive. As AI handles more execution, the premium on human judgment increase, not decrease. Your most valuable senior engineers are not the ones who write the most code. They are the ones who make the best decision about what to build, when to build it, and when to stop it. So the judgment gap is widely. Make sure your team is developing on the right side of it. Two concepts that I find myself returning to consistently when coaching engineering leaders in the agentic era. Context collapse is what happens when AI agent generate code without the organizational context that makes it appropriate. And the code is technically correct. It passes the test. It might even be elegant, but it is architecturally wrong for this team. And so this kind of code base, this moment, context collapse is not an AI failure. It is a leadership failure. Context is the leadership deliverable. If you haven't written down any of your architectural principles, your team conventions, or your current priorities, you cannot expect an AI agent to infer from them. So compare the bad with versus sad distinctions is a tragic framework for the code review. So bad code is flexible with the PR. This means run algorithm mission tests or style evaluation. An agent are excellent at fixing bad code, but the sad code requires a conversation. It is technically correct, but it reflects a misunderstood requirement. It is maintainable in theory, but not by its team. So, or it solves yesterday's problem, but not for today. So sad code is communicational failure, not a technical one. Only humans can fix it, because fixing it means going back to the conversation that should have happened before the code was written. So as a leader, your job is to distinguish between these two and bad versus sad code, and to create conditions where the sad code is caught before it is merged. Our second guiding question shifts from the quantitative to the qualitative. So the 6 metrics tell us what is happening at a repository level, but how do we detect the subtle shifts, the changes in how humans and AI agents are actually collaborating? How do we know if the collaboration is healthy? How do we spot the warning signs before they become problems? So the next 4 slides address this, the judgment gap, the context collapse, behavior indicators, and how all of this kind of translates to a specialized domain like the bioinformatics or life science, where the tasks or the risks of a wrong pipeline are not just a failed test, but a misdiagnosed patient or a retracted paper. This slide is the operational playbook for detecting the collaboration shift. The green flags are the signals that tell you the human-AI collaboration is healthy. Rising common density with rising throughput means your team is tackling big problems and review them seriously. New contributors converting to returning contributors means your onboarding is working. Reviewers asking why questions means they are engaging with the design, not just the syntax. The warning signs in the middle are the clear and earlier indicators of the collaboration that is drifting towards rubber stamping or context collapse. Cycle time falling while comment density also falls is the most dangerous compilation. It means PRs are merging faster with less scrutiny. High throughput with a rising post-merge bug rate means your quality gates are not catching what they should. The leadership actions on the right side of the blue section are the concrete and measurable and implementable for this quarter. Check comment density monthly and build the first PR to second PR conversion into your OKPRs. Require architectural rationale in the PR descriptions, not just what a PR does, but why this approach was chosen over alternatives. The goal is to make the invisible visible. Human AI collaboration shifts happen gradually, and then suddenly this matrix give you the earlier warning system. I also want to spend a moment on bioinformatics specifically because the stakes are different here. In software engineer, a bug is a bug. You fix it and you ship a patch. You move on. In the bioinformatics, the pipeline is an experiment. A run parameter, the run genome build, the run normalization method, and also the run sample grouping is not a bug. It is a scientific error that may not surface for months, and when it does, consequences can be severe. Retracted papers, misdiagnosed a patient, wasted grant funding. So the wet lab to pipeline handoff is where context collapse is most dangerous. A wet lab scientist specifies biological content and intent. A bioinformatician translates that to computational logic. An AI agent generates a pipeline code. Each translation step loses context. By the time the code is running, the original biological intent may be unrecognizable. So the solution is to treat the context as a first-class artifact. Experimental design document live in the repository. Sample metadata is versioned alongside the code, and also the biological intent is written in a plain language that the AI agent can read before generating the code. And the human-in-the-loop checkpoints are non-negotiable. The wet lab scientist reviews the pipeline logic, the bioinformaticians reviews AI-generated steps, both sign off before the production run. So the 40 minutes pipeline story from the opening of this talk is the model. AI collapsed the generation time from 3 days to 40 minutes. The review time did not change. That is the right ratio. The 6 metrics that I proposed are not just for software engineering teams. They translate directly to bioinformatics cores and computational biology groups. You just need to rephrase what each metric is measuring. PR throughput becomes pipeline iteration speed. How fast can your team test a new normalization methodology, add a new sample type, or update a reference genome? In the agentic era, this should be measured in hours, not weeks. Cycle time becomes a validation turnaround. The question is not just how fast the code merges, it is how fast you can validate the pipeline change, produce biologically meaningful results on a test dataset. Contributor bias becomes cross-disciplinary collaboration. The most valuable signal is whether wet lab scientists, clinicians, bioinformaticians are all contributing to the pipeline specifications, not just the computational team. Comment density becomes scientific scrutiny. Are biological assumptions being challenged in code review? Are reviewers asking why the genome is built and why this normalization methodology is used? Not just does this code run and work. Merging efficiency becomes pipeline acceptation rate. What fraction of the proposed analysis survive biological validation? A low acceptance rate is not necessarily bad. It might mean your team is being appropriately rigorous, but a declining acceptance rate with rising throughput is a warning sign, as I mentioned before. And contributors diversity becomes knowledge transfer. Wet lab scientists becoming pipeline contributors. Bioinformaticians becoming enough biology to catch the context collapse before it happens. I want to close a data section with the through truths, and I think are generally uncomfortable, and not because they are pessimistic, but because they require leaders to change how they think about their own role. Truth number one, your throughput benchmarks are already absolute. If you're still measuring team performance against the era 0 to era 1 baseline, you are measuring the run sim. A team merging 50 PRs per month in 2026 is not performing well. It is performing at 2023 levels. The era you are in determines what good looks like. Truth number two, the bottleneck has moved from the code generation to architectural judgment. Your senior engineers are not becoming less relevant. They are becoming more relevant. But their value is no longer in writing code. It is making the architectural decisions that determine whether the AI-generated code is building the right thing and the right architecture. If you are still evaluating senior engineers on code output, you are measuring the wrong thing. Truth number 3, context is now a leadership deliverable, not a nice to have. AI agents generate code from context. If your architectural principles, team conventions, current priorities are not written down and kept current, you cannot expect the AI agent or the new contributors to infer them. Context documentation is not a documentation task. It is a leadership task. It belongs your OKRs. So these 3 truths are uncomfortable because they require leaders to change how they measure their team and what they value and what they personally produce. But they are also liberating because they clarify exactly what leadership looks like in the agentic AI for the software engineering management and tech direction. The third and the final guiding question is the most practical one. We have seen that the data, we understand the human signals, we use the 6 engineering and team evaluation metric, and also develop the leadership framework across the 4 areas. Now, what do we actually do? How do we measurably improve the team's ability to deliver the production code in the agentic coding era? The closing slide brings it together, not just a list of the abstract principles, but as a set of concrete commitments that engineering leaders can make this quarter. The ground is still shifting. The question is whether you are shifting with it or being shifted by it. So for the final slide, and I'd like to wrap up for today's lecture. We have covered a lot of ground today. Let me bring it back to the 3 questions we started with. How should engineering managers and tech directors lead their teams as AI coding capability accelerates? Measure the right thing. Track all 6 metrics monthly. Update your era benchmark and make the data and also the code submission visible to the whole team. How do we detect and evaluate shifts in the human AI collaboration and the interaction patterns? Watch the green flags and the warning signs. Track the comment density as a leading indicator and build the first PR to second PR conversion into your evaluation forms. Rotate review assignment to prevent the rubber stampings. Number 3, how do we measurably improve the team's ability to deliver the production code? Invest in architecture judgment, write down the context, version your architecture principle alongside with your production code, make the biological intent or produce the intention of first-class artifacts. The ground is still shifting. VLM and SGLM are merging over 1,000 PRs per month. The era of agentic coding is not coming, it is here. And the question is not whether your team will be affected, it is whether you will lead from the front and be led by the data. So free code is the easy part, but the expensive judgment is what you are actually paid for. Thank you. That's all for today's lecture.